Hi everybody, today is May 27th and we are going to be looking at the following questions. Number 1, what is pH? And number 2, how can we detect the pH of a substance? So first off, let's start with the official definition of what the pH value of a substance is. It is the negative log of the hydrogen ion concentration. It's also could be stated as the negative logarithm of the hydrogen ion concentration. Please be aware it'll be when you take Algebra 2 that you would encounter logarithms. So on our last lesson, I had this pH scale drawn and we started filling in some of the concentrations of hydrogen relative to hydroxide. Okay, and as a reminder, the strongest acids have a pH of 0, and the range of acids could be from 0 to 6.9. Whereas 7.1 to 14 would be the pH range for bases. And bases with a pH of 14 would be the strongest bases. So when we're looking at concentration of hydrogen and hydroxide ions, we are looking at molar concentrations. So it is moles of hydrogen ions per liter or moles of hydroxide ions per liter. The strongest acid will have 1 times 10 to the 0 or 1 molar concentration of hydrogen ions. And the strongest base will have 1 times 10 to the 0 or 1 molar hydroxide ion concentration. Another quick reminder, a strong base, pH of 14, will have lots of OH ions, but it'll still have a very small amount of hydrogen ions. Because these substances are all dissolved in water. So, our pH scale ranges from 0 to 14. 7 is neutral, where we have equal hydrogen and hydroxide ion concentration. And that was 1 times 10 to the negative 7 moles per liter for a neutral substance. Okay, so let's talk about this pH definition here a little bit more. A logarithm is basically the inverse of an exponent. So let me try to explain that. What we're talking about here in pH are what we call base 10 logs. So if x equals 10 raised to the exponent y, that's an exponent, then the log with the base 10 of x will equal y. So let's look at some examples. Let's say we have 10 to the 2. 10 to the 2 in extended notation is 100. The log of 10 to the 2, or 100, is 2. If we have 10 to the 1, that is equal to 10. The log is 1. And likewise, we can go down this list here, and I will be using some more examples. If we relate this back to our pH scale, for example, 10 to the 0, 1 times 10 to the 0 is the strongest acid, and that is equivalent to 1. The log is 0, and that gives us the pH of the strongest acid. 10 to the 2, 0.01. The log is -2, And that will, the absolute value, will correlate to a pH of 2. And we could do this for all of these pH values, but let me jump way ahead. 0.00000, I won't say all those zeros, right? 10 to the negative 14 is represented this way. And that is, the log is negative 14. And that correlates to a pH of 14, which is the strongest base. So these are all representative of hydrogen ion concentrations, because we're looking at pH here, the power of hydrogen. The strongest base with the least amount of hydrogen ions has 10 to the negative 14. So let's go back and think about our pH definition. Always remember that hydrogen ion concentrations and hydroxide ion concentrations are in moles per liter or molarity. And let's look at an example of a pH problem. So in this example, if a solution has 0.0000001 molar hydrogen ion concentration, what is its pH? Let's plug that in. pH equals the negative log of the hydrogen ion concentration. Therefore, it equals the negative log of 10 to the minus 7. I could have brackets or parentheses here, by the way, at this point. That's fine, right? There's 1, 2, 3, 4, 5, 6, 7. 1 times 10 to the minus 7 is that concentration. So that pH equals the negative of a negative 7, and 2 negatives makes a positive. The pH equals 7. The power of hydrogen is 7. Let's look at another example. If a solution has 0.001 molar hydroxide ion concentration, what is its pH? So now this one, we need to think about the power of the hydroxide first, and then think about how that relates to the hydrogen concentration. So POH, by the way, has the same equation. It's the negative log of the OH ions, though, okay? That equals the negative log of 10 to the minus 3. Well, where did I get that? 1, 2, 3. Therefore, it equals negative 3. So the POH actually equals 3, the power of the hydroxide. Now, if you recall from the lesson yesterday, and if we just quickly look back here, remember the hydrogen and hydroxide ion concentrations are relative to each other. So if POH is 3, and the pH scale is a total of 14, 14 minus 3, the POH, gives us 11, which would mean that's the power of the hydrogen. These two values are always going to equal 14, which is the whole full range of this scale. So what is the pH value? It is a pH of 11. The question could have said, what is the POH value? And in that case, it would be a POH of 3. So this, by the way, is a basic solution because its pH is 11. And that's falling right about here. And that's 1 times 10 to the negative 3 hydroxides and 1 times 10 to the negative 11 hydrogens. Let's look at a third example. What is the pH of a 0.0001 molar sodium hydroxide solution? if we look at table L, we would see that this is a base. Okay, and a hint there is it has that OH with a metal. So it's a hydroxide releaser when it's placed in water. So we're going to expect the pH range logically to be above 7.1. But let's look at how we're going to do this. Just like the last problem, we did 1, 2, 3, 4. So that's 1 times 10 to the negative 4 molarity. And that's the molarity of the hydroxide ions. So we do POH equals negative log of the hydroxide ions. It equals the negative log of 10 to the negative 4. It equals negative 4. It equals POH of 4. Now, this question is asking for pH though. So 14 minus 4 gives us 10, which is the pH. And that should make sense, right? Because this is a base, and here it is, where you have 10 to the minus 4 hydroxides relative to 10 to the minus 10 hydrogen ions. Let's look at a fourth example. What is the pH of a 0.01 molar nitric acid solution? This, we're going to know that this is an acid. Why? Because we're going to see that in table K. So we know our pH should range between 0 and 6.9. We're talking about an acid here that's going to release that hydrogen ion. So we've got 1 times 10 to the minus 2, correct? And we're just going with the pH value here because it's an acid. It's not POH. So pH equals negative log of those hydrogen ions. It equals the negative log of 10 to the minus 2. It equals negative of a negative 2. It equals a pH of 2. And that does make sense because it falls right here on the acidic side of the pH scale. To wrap up this mini lesson, we're looking at these two final examples here, and I want to add a few more notes, okay? Anything with a pH of 10, it's approaching that pH of 14, so it's becoming a stronger base, okay? And a pH of 2 is certainly approaching that 0. It's certainly a strong acid. Strong acids and bases completely ionize or dissociate when placed in water. That's what makes them strong, because you're going to have more hydrogen ions or more hydroxide ions dissociating into that water, making the concentration greater, making it either a strong acid or a strong base. Whereas weak acids and bases do not completely ionize. And they're going to fall, closer to that pH of 7 range. They're weaker acids or bases. That concludes today's lesson. I hope you enjoyed it. Have a great day. Bye.